All right, so continuing our talk of how to graph different things. So we have x squared over x squared minus 4. Guys. All right, so I told you guys I'm not going to give you another homework assignment on this because it takes a long time, but there's probably going to be a quiz on this, right? So if I have x squared over x squared minus 4, then its domain is going to be everything except 2 and negative 2, right? Because x squared minus 2, when it equals 0, is plus or minus 2. So your domain is negative infinity to negative 2, union, negative 2 to 2, union 2 to infinity.
Why don't you set the you said the numerator equals 0 to 0, right?
Yeah, but the numerator is not part of, it's not affecting my domain. All right, the vertical asymptotes then are at x equals 2 and x equals negative 2.
Why just the numerator? Like, why just the numerator?
Because domain is affected by square roots, denominators, anything where it's not, like x can't be a certain number.
Yeah.
All right, so the first derivative. So I'm going to do low d high minus high d low all over the square of what's below.
Do you still have to say it to yourself?
Yes, I do. Do you still have to say it to yourself in your head?
Yeah.
All right, so let's see, only like 14 years that I've been doing calculus, I still have to say it. All right, so anyway, so I'm going to multiply the 2xn. So I'm going to get 2x cubed minus 8x minus 2x cubed all over x squared minus 4 squared. So the 2x cubes go away. So we have negative 8x over x squared minus 4 squared. So with this first derivative, we really want to know like where it's increasing, where f is increasing and f is decreasing. So I'm going to do my little number line. And I have critical values at x equals 0 from the numerator, and x equals 2, and x equals negative 2. So Bob, maybe that's why you were thinking about the numerator earlier, right? So I'm going to have negative 2, 0, and 2. And I'm going to test in each location. So what I like to do is I do like little dotted lines on the negative 2 and the 2, just so I remember that those aren't maxes and mins. Okay, that's where the original had a vertical asymptote. Okay, what if the original was defined, but then the first derivative was undefined at 2 and negative 2? What does that mean? Corner or cusp. Okay, so always keep those same things in mind. So if I plug in negative 3 into my derivative, the nice thing about plugging into the derivative is the bottom is always positive, right? I had x squared minus 4, but then I squared it. So whatever number I plug in down there, it's always going to be positive because of the square. All right, so if I'm plugging in negative 3, I have negative 8 times negative 3. That's a positive number. If I plug in negative 1, that's also positive. If I plug in 1, I get a negative on top because negative 8 times 1. And if I plug in a 3, I get a negative. So that means the graph of f is increasing, increasing, decreasing, decreasing. So based on that information, I know that I have a max at 0. So we don't know if it's absolute or if it's local, just a local. But all right, so when I do my second derivative, this is where it gets a little bit tricky when you have like the squared thing on the bottom. So I have f double prime of x equals low d high minus high d low. So d low is a little bit hard because you're going to have 2 times x squared minus 4 to the first times 2x all over the square of what's below. Oh, so now it's still the fourth. So I'll just do squared squared. All right, now this always happens with the second derivative when you have these quotients. See how I have an x squared minus 4 twice? I go ahead and at this point, I pull that common factor to the front. Because what's going to happen is you're going to have to factor in the end anyway to find where it's equal to 0. So it's just easier than like multiplying it out, like FOILing out, multiplying it in, simplifying, and then factoring. So if you can remember that to pull out the common factor, it really does save you a lot of work. So I'm going to have x squared minus 4 on the outside. But then on the inside, I still have another x squared minus 4 times that negative 8. And then I have a plus, because I have negative negative, so I'm going to say plus 8x times 2 times 2x. All over x squared minus 4 to the 4th. But now do you notice you have an x squared minus 4 on top? And you had 4 of them on the bottom, so now you're down to 3 on the bottom. You can reduce one of them. So you have negative 8x squared plus 32. And then I have plus 32x squared all over x squared minus 4 cubed. Okay, so then I get 32 minus 8, so I have 24 x squared plus 32 all over x squared minus 4 cubed.
Gee.
I know. So I'm going to set each piece equal to 0. So on the bottom, I'm still having the plus or minus 2, because those are definitely critical values because they were the asymptotes, right? Okay, so if I set the top equal to 0, am I gaining another critical value? Set your numerator equal to 0 and solve.
No, you're not, because it's,
Right. It would be an I answer, right? You can see that we're not going to deal with I's. We don't have it. So there's nothing else from there. So all we get are our plus or minus 2. So I put my f double prime, so now I'm trying it in the second derivative. So the numerator is always positive. The denominator now could be negative. Do you guys see that? Because now it's raised to the 3. So if I try 0, the top's positive, the bottom is negative 4 cubed, it's negative. If I try 3, it's positive, and if I try negative 3, it's also positive. So it means I'm concave up, then concave down, then concave up. This second derivative information really didn't tell us much, right? Could you tell that it was going to be concave up, concave down, concave up from the information? I could tell because I knew that there were asymptotes. Okay, so sometimes you may not even need that second derivative stuff. All right, so next up. So it asks for the horizontal asymptote. So your original was x squared over x squared minus 4. So I told you the shortcut for finding the horizontal asymptote is look for your largest degree, so x squared over x squared, and divide them out. So you get 1 over 1, so we get 1. Okay, there's actually a really long way to do that. I've shown you that before, right? Like divide by x squared everywhere, take the limit. Yeah. All right. You guys are like, no, we've never seen it, but we don't want to see it. We're good. All right, intercepts. So if I'm finding the x-intercept, I plug in 0 for y. So that means my original is going to be equal to 0. So 0 equals x squared over x squared minus 4. I have a fraction equaling 0. The only way that's happening is if my numerator is equal to 0. So if x squared equals 0. So I get x equals 0. So that's the point 0, 0. That's both an x-intercept and a y-intercept. The y-intercept, I plug in 0 for x, right? That's giving me 0 because I'm going to have y equals 0 squared over 0 squared minus 4. I get 0, which I knew the y-intercept already. I knew it was 0, 0. Okay, so this leads us to our sketch. So with our first derivative and second derivative information, we usually know that we need to find maxes and mins and points of inflection. So for the first derivative, I would need to find f of 0, which I just found. I found it was the 0, 0, right? All right, that's going to be a max. So at 0, 0, I try to do a little curve. So remember that's a maximum point there. All right, and then I have a horizontal asymptote of 1 and vertical asymptotes of -2 and 2. So I can tell, in the middle, I'm doing that, a little parabola shape. And then on the right side, what we did in Algebra 2 is we always just plugged in a point to find where it was going to go. Can you guys tell where it's going to go? It has to be concave up, and it has to be decreasing. It's going to go right here. Does that make sense? And then the other one has to be concave up and increasing, so it's going to go here. There are no points of inflection. There's only a local max. So local max of 0 at x equals 0. Okay, no points of inflection. All right, so slant asymptote. Do you guys remember this from algebra 2? Okay, occasionally you're going to have a slant asymptote. That's when the degree on top is exactly 1 more than the degree on the denominator. So I have x cubed over x squared. So this was degree 3. This was degree 2. So when that happens, we're going to have a slanted line. That's going to be our asymptote. Okay, and we find that by doing long division. So you can't, there's no shortcuts in AP Calc. It's still the same thing. I know, and divide by x squared plus 1. So I usually do x squared plus 0x plus 1. So I say, what do I multiply x squared by? I need an x. It's really not that bad, guys, I promise. So x times x squared is x cubed. X times 0x is 0x squared. X times 1 is x. What did I always say? Draw the line. Change the signs. You remember that? Add straight down. X cubes go away. X squareds go away. I get negative x. I repeat the process. Can I repeat the process? No, I'm not going to say what do I multiply x squared by in order to get a negative x. I don't write negative 1 over x. I can do that. Okay, this is your quotient, x. We want our quotient to be in the form y equals mx plus b, so it's just y equals 1x plus 0, right? So y equals x is my slant asymptote.
You don't do anything for the remainder.
Nope, nothing with the remainder. So that whopping 1 step that you all were all very worried about with long division, it took us 1 step. Yeah. All right, so that's our slant asymptote. Do we have a horizontal asymptote?
Yeah. Yeah.
No, you will never have a horizontal asymptote when you have a slant asymptote because your degree on top is higher than the degree on the bottom. It's like 1x cubed over 0x cubed. So no, do I have a vertical?
Yes.
No.
No.
Why?
No. Because it'll be an I.
It's going to be I, right? So we don't have a vertical either. Okay, so that helps us sketch our function. All right, so I'm not going to do this. You can find f prime. You can find f double prime. You can find where it's concave up, concave down, max, min, and all that. I'm not going to do all that. But you may have a problem where there's a slant asymptote. Would you be able to find the slant asymptote now? Yeah.
Long division.
Yeah. So it's probably going to be something, I don't know what it's going to be. I don't know, let's graph this one and see what it looks like. All right, so there ends up being a, like if you do your first derivative, you'll get a place where the first derivative is equal to 0, but it's not a max or a min. It's like one of those x cubed functions, like where it tapers off, but it doesn't like go back down. So I think the graph looks like something like this. Like it goes along the horizontal, or along the slant.
You can cross it?
Yeah, you can cross the slant. You can't cross it. All right. You can't cross a vertical asymptote. That's the only one you can't cross. Why can you not cross a vertical asymptote, guys? It's undefined, meaning that x value, if you plug it in, you don't get a point, you get undefined, right? That's the only reason you can't cross it.
Yeah, like if you can cross it.
Because on like a horizontal asymptote is telling you what's happening on the ends of your graph. On the end of the graph, you're not crossing. You're going along it on the ends. It's telling you the end behavior. You know, like in Algebra 2, what I had you guys do in your notes is I had you write like we talked about, like x cubed minus 2x. Oh, that's an x cubed shape. So on the ends, it's going to go like this, right? A horizontal asymptote doesn't do like, it doesn't go to infinity and negative infinity, or both of them. It goes along them on the end. Yeah, but you can cross in the middle. You've done tons of ones like this, right? Where you have something in the middle, something here, and something here. You've done that a lot. Yeah, it crossed it, right? Just not on the end.
Going to infinity.
No, it's not. As x goes to infinity, it's going towards that horizontal asymptote. As x goes to negative infinity, it goes along the horizontal asymptote.
Oh, and then because they're
Right, this would be one where it'd be like, limit as x goes to, I don't know, if this was like 2, as x goes to 2 of your function, right? You would need to indicate if it was right or left. In this case, it's okay. You can go towards 2. It would go towards positive infinity, right? They both go up. So we've done those limits before. All right. All right, so it says on the AP Calculus test, many questions can be quickly solved with graphing calculators if allowed. So if you're on the section that allows the graphing calculators. So you shouldn't waste time trying to evaluate y values for maximums, minimums, and points of inflection. So this is on your homework that I gave you. Guys, stop talking. On your homework that I gave you, and you guys did way too much work because you were finding all the maximums and mins by hand. Like, don't do that. If you have your calculator, if I say use your calculator, you may use your calculator however you want to. That's great that you practice. But some of them are going to be like almost impossible without using a calculator. So it says you could also, so you can use the maximum, minimum, and zero functions. You can also actually graph a derivative on your calculator. So I'm going to show you how to do that. Okay. So if you have f of x equals x to the 6th minus 15x to the 5th plus 75x to the 4th minus 125x cubed minus x, you could find f prime.
You can take on that.
Oops. Minus 375. Right? But if I ask you to set that equal to 0 and find its critical values, you guys are going to like panic. Do you see what I'm saying? If I put this on a homework problem, you would like freak out. And you're like, Mrs. Cox, this is so mean. Like, why would you do that? Because I want you to know how to use your calculator. That's why I would do that. Okay, so what we do is, let's go ahead and put this original function in for y1. Okay, so we're going to put x to the 6th minus 15x to the 5th plus 75x to the 4th minus 125x to the 3rd minus x. Okay, and it's all in for y1. Now you can hit graph and you can try to find the maximum, like the max and min and so on. But when I graph it right now, it's looking like I can't see all of it. Like something like that. Because I have my negative 10 to 10 window. So we need to adjust the window. This is where Blake was saying the other day, do zoom fit.
I don't understand why you do that.
When you do zoom fit, what does it show you? A terrible graph. It's just like it looks even worse. It's like this. Like it's going along the bottom, and then it like shows a little bit there, but it shows nothing below the axis. But clearly it goes below the axis because I just had that. Right. Oh man. All right. So let's change our window. And from my original one, I want to go down to, I don't know, let's try like negative 100.
What are the values for them?
So I'm doing like negative 10 to 10 for my x values, and then y min is negative 100. I don't know, I'm just playing around with it. Okay, still not low enough, right? Do you guys see it?
-5. That's gonna work.
I know it's an x to the 6th, so there has to be like a bottom somewhere, right? Does that make sense? Why does x to the 6th?
Like a crayon. Yeah.
500 is way too big.
I found the bottom.
What's your
I did 500.
All right, so I did my window. My x's, I made it -5 to 10. And then my y's, I made it -300 to 100, and it gave me a pretty good graph. So go ahead and put that in so we have the same thing. So -5 to 10 for the x's. And then I did -300 to 100. So when I do that, I have like a little like squiggle there. It goes down, and something else there. Do you guys have that? Yeah, kind of like the top of a crown. All right, if you don't have the same shape, then check your original. Make sure you put in the exact same thing. All right, so I can find this minimum, so go ahead and find the minimum. So second trace minimum. I went on the left side, left bound, right side, right bound. Guess, get right where you think it is. So I have 2.504, comma, negative 246.643. Yeah, so do 3 decimals. Now, if you aren't sure if you're going to need those values, like maybe you might need them later, like if this was like a story problem or something, you would want to store them. Do you guys remember how to store the x and the y values? Okay, so you're going to do second quit to get out of there and go to your main screen. All right, and then you're going to hit the value x and enter. See how it gives you 2.50426, blah, blah, blah. That's that x value that you just found. So we hit stow. So along the left-hand side, do store, stow, and store as like alpha A. And then I write that I've now stored that as A above it.
So where did they get y from?
So how do you think we get y? So we're going to do the y letter, so alpha y, and hit enter. That pulls up the y value. But you never want to store a y value as y, because anytime you go into a graph and find another point, it's going to use that next y value, right? So you want to store it as b. So store alpha b. Okay, so in story problems, you're always going to need to store these values. Like they make it so that if you don't store the value, you're off by, let's say it was a story problem about like cubic meters of oil. You'll be off by like 1,000 cubic meters of oil or something. They're going to make it so obnoxious. If you just do the decimal points, like you're going to be way, way off, right? Don't build my bridge in the future. Don't be an engineer, build a bridge for me and not store values, because you're going to be off by a couple feet at the end and I'm going to die. Like, don't do that. Yes. Yeah, so you're going to hit stow along the side. Did you already pull up x? So hit x first, like you're just normal x. No. So go back to your main screen. And then x, hit enter. See how it gives you 2.504? All right, now hit stow. And store as like a letter, like alpha A. All right, now I have no idea what's happening in these locations. Like it looks to me like it's looking like an x cubed graph, but I'm not sure. Okay, so I want to know what's happening with the first derivative. So I can try to zoom in on those different values and see if I get a maximum. Okay, but it's going to be really weird. So what I'm going to do is I'm going to have you guys graph the first derivative. So for y2, here's what you're going to put under y2. In deriv, so that's math 8. So in deriv, math 8. And then parentheses, y1, comma, x, parentheses. So some of yours might say something else. It might say when you hit an in deriv, it's going to do ddx. So you're going to have y1, and then it's going to have a line, which means evaluated at, and it's going to say x equals, hit x. So you want to put that in. Okay, so how do you get the y1? All right, don't just type in what you have for y1. That's a waste of time. So what we're going to do is, under y2, I'm going to do in deriv, so math 8. Do you guys all have that part? All right, under vars, do you see vars? It's underneath your cursors. Vars, that means variables. So hit variables, arrow over to y bars, function, y1. So it takes anything that was in y1 and it puts it in there.
So it's d over dx, y1 equals x.
All right, now let's deselect y1. Do you guys know what I mean by deselect? Don't clear it, just go on top of the equal sign and hit enter. So it's deselected. So I only want to graph the first derivative. So I'm hitting graph. It takes a little bit sometimes, especially second derivative it thinks for a long time.
But how do you clear the first one without erasing it?
Just hit the equal, like go on the equal sign and hit enter. So this was f of x was my original one. Yeah?
So to get the y1, what
Vars. So vars is under the arrows. Vars. Arrow over to y variables, y bars. Function y1. All right, so we have a really weird thing for the first derivative. Do you guys have it? Mine looks like this, and then it goes up, and then it comes back down. Right. I want to verify. This to me looks like 0, 0, but I'm not sure if it's 0, 0. So I'm going to do calculate, like second trace, and I'm going to hit value, and I'm going to hit x equals 0.
Me too.
Okay, it didn't go all the way to 0. Did you guys see that? Like it wasn't at 0, 0. So let's try to find the maximum.
There's no absolute max, right? So it goes off.
There's no absolute max, but there could be a max. Like I want to know what's happening right here. Okay, it's telling me that my maximum is really close to 0. Mine gave me like negative 5.127 e to the negative 7. That's really 0. That's a rounding error that your calculator is making. Your calculator does lie to you occasionally. So it's 0, comma, and that's really close to negative 1. I think it's negative 1. I'm going to do 3 decimals just in case. Negative 1.000. All right, so that means that it didn't go all the way up to 0, 0. Okay? So for my first derivative information, it doesn't actually hit 0 until, like I'm going to do the intersection, like find the intersect. What am I finding? Not intersect. I'm going to find the 0, like second trace 0. I'm going to do left side, right side, enter. I'm finding this point right here. This point is 2.504, comma 0. So that's the first place that I had a critical value. Like on my f prime number line, sometimes it helps to draw the f prime number line. Do you guys understand what I'm saying? Abby's giving me a really nasty look.
I went to find the 0, negative 1, and it didn't give me that. It gave me.
Yeah, it gave you a weird thing that was close to 0. That's what I was talking about. It's like in scientific notation. Negative 5.
You're right. I'm sorry.
All right, that's okay. So I'm always below. I'm below the axis until I get to that 2.5. So what that means is on my little number line, I have. Oh, sorry, I put a plus and I meant a minus. You guys could have gotten a bonus point, but I'm too fast. It's below the axis. Does that make sense? And then all of a sudden it's above the axis. But I want to know if it hits again. Do you guys see this little area right here? I want to know what's happening right there. So I'm going to do second trace minimum. And I'm going to find the minimum there. I think it doesn't touch, but we'll see. Ah, maybe it does. It does go below.
Yeah, it does.
Okay, so here's the weird thing. If it goes below, it dips below, there's two critical values that are really, really close to each other. Okay, so it was above, and then it dipped below, and then it went above again. So we need to know what those two places are. It's not multiplicity because it definitely went below. Like when I did my minimum, I got 5, comma, negative 1. Did you guys get 5, comma, negative 1?
I got 5, negative.
For the minimum?
I got negative, I got 4.99999.
Yeah. Yeah, mine was 5.000000021. Yeah, so that's a calculator error. Like it's probably 5. Okay. All right. So I want to find those two places. So I would find where they're crossing. So I find the intersection points. You probably have to zoom in on that area. Have you guys ever used ZBox?
Yeah.
ZBox? I love ZBox. It's my favorite Zoom. Can you have a favorite Zoom? All right, so I'm going to hit Zoom, and I'm going to do ZBox. So with ZBox, what I'm going to do is I'm going to get like around here. So like right here. And then I'm going to go over and down until I create a box, and then I hit enter. So I enter in that little location there. I go over, and then I go down until I have a little box, and I hit enter. And when I do that, it zooms in just on that little location that I had highlighted. How do you what? I hit zoom, and then I use number 1 ZBox. It's still pretty close. I still can barely tell.
Yeah.
That's why this is a calculator question. All right, someone next to Randy, can you help her with the ZBox?
Go to Zoom and hit Zoom box and just like.
All right, so I get 4.947. And this other one? Did you guys do the other 0 too?
This is probably more on.
Yeah, you can zoom in again if you need to.
It's like 4 times. This is probably this one.
Fourth Z box. Oh, that is nice. 5.051. All right, once you have that number line, you can really tell what's happening in this graph. So see why I put this one as a calculator question? It's so close. Like, how do you get these without like having a calculator? So you're going to have down, up, down, up. So that means that there's going to be a min of something at x equals 2.504, a max of something at x equals 4.947, a min of something at x equals 5.051. Does that make sense?
It's not my system.
How do you find those values?
You just plug it in. Or you can put the X values into
You can go to the table, but now I've just messed myself up because I didn't store those values. Do you guys see?
Oh.
Ah, annoying. I should have stored those because then I go back into my original to find the y value. Make sense? Why would I not store them? I don't know. I'm a terrible person. All right. I know. I didn't think about it. I should have. You always store just in case. But you can quickly find those again. You can find the max. All right. No, because you didn't correct me. I told you. All right. So do you guys see what's happening on this graph? So there is some kind of max thing that's happening there. Like you can't see it very well. There's like a min and then a max. I guess it's on the other side of the axis. So it's like over here. Like there's going to be a min and then a max. And then there's going to be a min again. So then we already found the min, didn't we? Wait a second. That's not where it is. I'm lying to you. Should have corrected me. Okay, it's happening. This one never tapers off to 0, actually. Do you guys see that that never tapers off to 0? Because it's getting really close to 0, but it's not actually. So it's never tapering off to 0. We have the min, which we had already found, this one, the AB. That's this one. And then on the right side, we have a max and then a min. So it's doing like a little like up and down thing there. Do you guys understand? Okay. And then there's one more like that. So you guys can do this one at home if you want, and you can check. But same thing. So it's still the end deriv, like you can do end deriv and so on and check. Yeah, and you guys can do end deriv twice. Like what if I wanted the second derivative?
Y2.
End deriv of y2, right? So then you can get the second derivative. It's a little bit annoying when you graph it though, because it takes a while to graph. It like has to think really hard about this point.
Wait, is it what we're talking about?
It could be.
It could be.